Today's a really special webinar because we're joined by special guest Katie Norton. She's a research analyst from IDC. We'll be talking about exposing critical software supply chain security weaknesses. Really quick, for those of us on the line who are not familiar with ReversingLabs, want to give a quick at a glance of who we are. We have the world's largest searchable threat repository of over 40 billion files. That's 8 times larger than the nearest competitor. With that, we are servicing over 60 cybersecurity companies that are trusting our data as well as feeding us data. And we're able to do that because we have the fastest file and software deconstruction engine. It allows us to analyze 20 million files a day, and typically 3 million of those are actually malware. We have 300 employees globally. We're a 5-star rated partner program. We're a recognized SSCS solution. And last one that I'm especially proud of is that we are a contributor to the Verizon DBIR report. So they're leveraging all the data that we have from all of this all the files that we're ingesting and analyzing. My name is Dan Petrillo. I'm the Vice President of Product Marketing here at ReversingLabs. But as I mentioned briefly before, we're joined by research analyst from IDC, Katie Norton, who will be sharing some really exciting data. Katie, I want to kick it over to you to introduce yourself and tell us a little bit about IDC.
Sure thing. Thanks, Dan. So for those of you who are not familiar, the International Data Corporation, or IDC, is the premier global market intelligence data and events provider for the information technology, telecommunications, and consumer technology markets. With over 1,300 analysts worldwide, IDC, we offer global, regional, and local expertise on technology and industry opportunities and trends in over 110 countries. Our analysis and insights help IT professionals, business executives, and the investment community make fact-based technology decisions and help them achieve their key business objectives. And we've actually been recognized by the Institute of Influencer and Analyst Relations as the global analyst firm, I think for 4 consecutive years now. So, and then I think we move on and talk a little bit about myself and my research, which I think kind of transitions nicely into, it's kind of this, supply chain by the numbers, right?
Yeah, I love that you say fact-based decisions. So give us some of those facts and we'll dive into what they might mean.
All right. So quickly, at IDC, I lead our DevSecOps app vulnerability management and software supply chain security research practice. And so a core area of my research for the last several years has been on securing the software supply chain. We at IDC have really strived to be, I think, thought leaders in this space. And we've really been looking to raise awareness and help organizations understand what it is they need to do to avoid being the next victim in the headlines. And, for many organizations, the supply chain remains I think the least visible and the least protected part of their attack surface. So since 2021, we've really been consistently producing reports, which many of you can see here in screen grabs about this topic. And so what I wanted to do today was share with you some of my findings and really dig into what some of these big weaknesses are in the software supply chain.
Great. Are you able to control or would you like to pause?
No.
Okay. Sorry about that. Technical difficulty on my end. You just let me know when to move forward, Katie.
All right. Easy peasy. So first, I just want to present some stats that we have on what sort of the state of software supply chain attacks look like for most organizations. In our most recent survey from July 2024, we saw that almost 1 in 5 organizations indicated that they experienced a software supply chain attack in the last 12 months. And generally, we can assume that these stats are kind of underrepresented, knowing that oftentimes organizations tend not to want to disclose this type of information in surveys, even if it's anonymous. But, I think this statistic is really a stark reminder of how this threat landscape has evolved. Historically, attackers targeted applications directly, right? Looking for vulnerabilities in the code, exploiting unpatched systems, or using phishing to gain access to app environments. But today, I think the focus has really shifted upstream to the supply chain itself, where the attackers have a broader and honestly more insidious impact. And, you know, why target a single application when you can compromise the supply chain and affect hundreds or even thousands of downstream applications and organizations? By infiltrating the development pipeline, whether that's through malicious code in third-party libraries, compromised open source dependencies, or even breaches in the CI/CD pipeline, you know, attackers, they really gain with software supply chain attacks is a multiplier effect. One breach upstream can cascade, you know, to multiple downstream, creating this sort of ripple effect of security incidents. And another thing here that I think is driving this is that the economics incentive is huge. Supply chain attacks really allow attackers to compromise many victims while expending the same or even less effort than attacking each target individually. They're not just attacking one organization, they're attacking trust. When attackers compromise a well-known vendor or a library, like we all experience with Log4j, they undermine the confidence in the very foundation of modern software development.
Yeah, that makes sense. You can really see why it's an appealing technique
Yes.
for the threat actor. I also really like this chart. Well, maybe like isn't the right word, but it's very interesting because if you look at the lowest one, you have 0-day exploits, yet I would say that gets the most, you know, media attention. So there doesn't seem to be a correlation between what folks are experiencing and what folks are talking about. I'm just wondering why that is.
Yeah, no, I agree. And so another piece of data I wanted to share too is actually around ransomware, which is not something we always talk about, the intersection of that with supply chain security, but this was some really interesting research that we did. And we found, you know, I think first to kind of set some context here, we all know ransomware continues to be probably one of the most pervasive and damaging threats organizations face today. When you know, talk to them, ransomware always comes, you know, to the top of the list in terms of concerns, because these attacks have become more frequent, more targeted, and ultimately more damaging. But a key factor behind this rise of ransomware is that it gives attackers sort of a variety of ways to directly monetize an attack, kind of tied to what we were talking about earlier, right? With there's always an economic incentive to these, right? And so unlike previous generations of attacks, which required actors to steal and resell data like credit card numbers or PII on the black market, ransomware actors can immediately monetize a successful attack by extorting the victim directly. However, organizations have a blind spot in the area where ransomware has become the most active, and that's the software supply chain. And so we have some IDC research that found that software supply chain attacks were the second leading source of compromise for ransomware incidents in these surveyed organizations at 16%. And, you know, this data is compelling, and it's a compelling example of how the lines between different types of cyber attacks are blurring. We tend to think of ransomware as a direct attack. An employee clicks some phishing link or malware encrypts a critical system. But what this stat shows is that nearly 1 in 6 ransomware incidents originate from a software supply chain attack. And this is a significant shift in the threat landscape. So I want to unpack a little bit about why this is happening. Ransomware groups, like other attackers, are opportunistic. They've realized that compromising the software supply chain, it gives them an efficient pathway to distribute their payloads to multiple targets. Instead of breaching individual organizations, they compromise a shared dependency. So when those components are integrated into production environments, ransomware can spread far more quickly and broadly than through traditional methods. And, you know, whilst only some organizations have these like large amounts of payment data or PII that can be resold, every organization you know, they have a business that can be disrupted, right? And they're, you know, if their systems are offline or sensitive data that could be damaged if leaked. And really, when you look at Kaseya, which is a pretty, you know, it's maybe doesn't have it doesn't have quite Log4j status, but it was a pretty well-known incident. And really there was a big ransomware tied to this, right? Attackers compromised the software solution that's used by MSPs, infecting them with ransomware, which was then deployed together with their software update. And this ransomware spread to thousands of customers' environments, and it allowed attackers to extort, you know, over $70 million from these MSPs and their customers. So there's almost kind of, twofold here in what that blast radius looked like. So I think ultimately what this stat really highlights for me is that ransomware isn't just an endpoint problem, which is sometimes how we think about it. It's an ecosystem problem, and that every link in the software supply chain, has to be scrutinized and secured and monitored, because as we've seen, attackers will exploit any gap. And, these consequences are, whether they're financial, operational, or reputational, they're really too severe for us to ignore.
Wow. Yeah. This stat was really eye-opening to me too, and alarming in a lot of ways. So, when software is the catalyst of a ransomware attack, it's most likely that it was a software supply chain attack. I, typically would have thought, a few years back, software supply chain attacks were low probability but high impact events. This is saying they're high probability and high impact, which is not really what we want to see.
Yeah.
Um, let's define the supply chain a little bit, Katie, if you don't mind.
Yes, I think it's now that we've sort of seen these alarming stats, that I think it's clear that securing the supply chain isn't optional. But before we dive a little bit deeper on like what we need to do, I think it's really important to step back and define what exactly we mean by a supply chain, right? Because I think the way we've been talking about it over the last years, maybe it's been a little cloudy, and I think one of the biggest challenges organizations have with the software supply chain is actually understanding what it is. So I think to ground the discussion, I'm using actually the Corporate Finance Institute's definition of a supply chain. Like, not even, let's take software out of the mix,
Sure.
to start. And I think it provides this like clear and structured way of understanding what a supply chain is. And that's, it's the entire system of producing and delivering a product and service from the beginning stage of sourcing to the raw materials and the final delivery of the product or service to end users. And so I think to like understand this even more, it helps to let's, look at this broader concept with a visual representation.
And
Dan, if
bring
you
out your lunch or
want.
breakfast, because this might make you hungry.
Yes. So when I'm talking about the supply chain with people, I think that like looking at it in this way really helps. And so we're gonna make this concept a little more tangible by using the example of a Cheerios factory. To be quite honest, I was originally going to do this with my favorite cereal, Lucky Charms, but I did not know how to map marshmallows that are in the cereal and what their ingredients were. So to think about it, everything that goes into getting a box of Cheerios onto the grocery store shelf is kind of, high level here mapped. It starts with sourcing the raw materials like oats, almonds, honey, and those ingredients are then transported into a processing facility, right? Where they're milled, they're mixed, they're shaped, they're baked. And from there, the finished cereal is packaged and shipped through distribution networks. And finally, delivered to your local store. And, every step along the way represents a part of the supply chain. But I think here's the key point. If something goes wrong at any stage of this process, so say the oats supplier delivers contaminated grain, or the processing facility worker forgets to wash his hands, or the packaging machine drops a shard of metal into the bag while it's making it, or the grocery store doesn't rotate its stock and it's putting expired product out, the impact cascades down the chain. It could lead to product recalls, delays, or even harm to consumers. So now let's translate this into software, right? So the software supply chain, you could see the raw materials as the components, like your open source libraries or your APIs or even custom code. And these components are brought together in the factory of your CI/CD pipeline, where they're integrated, tested, and built into, an application, into a binary. And then the final product, your software is distributed to users through deployment processes. And just like with the Cheerios, every step in the software supply chain is interconnected, and a weakness in one part can compromise the entire system. So I think what this diagram highlights is that the software supply chain isn't just about the ingredients. And I think sometimes when we're talking about this, we tend to overfocus on those ingredients. And while open source components are a significant part of the conversations, they're not the whole picture. And we're tending to overlook other critical elements, and like the tools and the infrastructure that make up the factory, right? You have to have physical security in a factory that's making Cheerios, just as you do software. For example, the security of your build systems, the integrity of your deployment processes, even the practices of third-party vendors that you are integrating with all play an equally important role. So a breach in any of these areas can be just as damaging as a vulnerability in an open source dependency.
Yeah, that's so true. And I stole this analogy from Katie with her permission at a talk I gave a couple weeks ago. And I actually mapped some famous attacks to this analogy. So I mapped where it went wrong with Orion and with 3CX and XZ and UA parser. And it really highlighted, if you've got controls on this end, but the issue happens later, you're going to have missed it. So shift left, love it, great mentality. But it's not a panacea, right? There's still things that can go wrong, and so I think it's a really good analogy to use when you take a look at your tooling and see where you feel comfortable, and to look at how attacks could maybe bypass what you have in place right now.
Yeah, agreed. And so I think now, Dan, that we've sort of laid this groundwork of understanding, we can jump in a little bit into some of the risks associated with the supply chain that organizations need to think about. And to do that, I'm going to go about it, in providing this, my advice or point of view on how, the things organizations should be thinking about. I want to highlight some, I think, common mistakes and just general misconceptions that organizations have about what it means to secure their software supply chain.
Cool, let's do it.
All right. So misconception one, that your DevSecOps AppSec tools are sufficient to protect the software supply chain. This slide shows a variety of tools. This in itself is not entirely comprehensive, but highlights just some of them that are available in the modern DevSecOps ecosystem. And, what I'm trying to highlight here is this important distinction that securing the application itself is not exactly the same as securing the software supply chain. Throughout the infinity loop on here, you see some of the traditional tools we associate with DevSecOps and AppSec, like SAST, SCA, DAST, your WAF, API security, RASP. These tools are all essential for identifying vulnerabilities in your code, monitoring runtime behavior, and protecting applications from being exploited. But they focus on securing, what it is that you build and ensuring that the software you deliver to your users is free of known vulnerabilities and can withstand active threats. But here's the challenge. These tools are designed to secure the application, but not the process and the components that contribute to building the application. Organizations often believe that if they're using, like software composition analysis, and they scan their open source dependencies for vulnerabilities, that they're adequately protecting their software supply chain. And while SCA is an important non-negotiable piece of the puzzle, it's not sufficient on its own. And software supply chain is much broader and requires a different set of security measures. So what I've kind of put surrounding the infinity loop are some of the tools and practices we see aimed at securing the software supply chain. This can include developer identity and access management, and also didn't even mention here, like developer machine and SDL machine access management to prevent unauthorized access to critical systems, provenance tracking to ensure that components come from trusted sources, attestation to verify that each step in the build and deployment process is what it says it is. You've got tools like reproducible builds, software builds and material, and pipeline or CI/CD security to make sure that your workflows are protected from tampering. And you also have malware detection focused on catching malicious code being introduced anywhere in the pipeline. And so I think the key takeaway here that I want to drive home is that securing your applications and securing your software supply chain, they're complementary but distinct efforts. And that application, I think maybe the best way to put this is application security tools address the what, but supply chain security tools address the how.
Yeah,
That makes sense.
that's well put. It does. And I think it speaks to some of the challenge, right? It's a broad challenge with a lot going on.
All right.
On to the
Number
next
two.
misconception.
Yeah. Number two, S-bombs are not the supply chain silver bullet.
Darn it.
Ah, darn. We thought we had it solved. Um, S-bombs have been a really hot topic of conversation. If you're anywhere lingering on the internet or LinkedIn, lots of debates continuing. And, a lot of that's been driven by the US executive order and other, the CRA and a whole bunch of other regulations that are starting to make these a requirement in some sectors. And it's true, they're really valuable. And I'm an SBOM fan, but they're just that, they're a tool, and SBOMs alone won't secure your supply chain. An SBOM provides that detailed inventory of the components in your software, including libraries, dependencies, and other elements. It's like that list of ingredients on the Cheerios package, right? And it helps you identify what's inside, right? And whether any, when you combine it with other tools like Vex and, vulnerability reporting, you can compare those components and identify those that have known vulnerabilities. And this is incredibly useful, especially when you had SBOMs maybe been at the state of adoption, which, the stat on the screen here is from our survey showing, what kind of stage folks are at with adopting SBOMs. That had Log4j happened right now, we maybe would have been a little bit better off than we were when that happened, and SBOMs weren't, while they existed, weren't quite as prevalent as they are now. But the thing is that SBOMs, they don't prevent those vulnerabilities from entering your pipeline in the first place, right? It doesn't tell you if the source of a dependency was compromised, or that if your CI/CD system was tampered with, or if that malicious code was inserted during the build process, because this bad stuff doesn't just enter in the open source ecosystem, right? In other words, SBOMs are really great for visibility, for transparency, but they only address part of the problem. And, this is similar to the misconception we discussed, in the first around SCA. SBOMs and SCA, which, are closely linked, they focus on identifying these known issues, and they don't protect that broader supply chain ecosystem. And these are really critical areas that need to be addressed, alongside SBOM adoption. So while these SBOMs are an important step, I don't want you to walk away saying, Katie Norton said, forget SBOMs, because that's not what I'm saying. What I'm saying is that they improve transparency, but they're not the complete solution, right? They're a piece of a much larger puzzle. And, to really, truly secure your software supply chain, you need to take this holistic approach where you're combining SBOMs with other tools and practices that address that full life cycle of software development and delivery.
I think that's very fair to say.
All right. I don't want any quotes. Katie
Yeah.
says SBOMs are bad. All right. Number three. And our third and final misconception that we're going to dive into. One problem is that we tend to over focus on CVEs, those publicly disclosed vulnerabilities with an assigned identifier. A really alarming IDC data point to consider is that in our survey from July, we found that 69% of organizations are not scanning their binaries for malware. And this is a significant oversight because malware introduces a whole different class of risks that aren't addressed by simply, tracking, identifying, and remediating CVEs. So let's break this down a little bit. CVEs, they represent those known vulnerabilities, right? Those flaws in software that have been identified, they're cataloged, disclosed to the public. And tools like SCA and SBOMs, they're great for these and dealing with those issues. But malware is fundamentally different. It's not about a flaw in your code. Really, it's about malicious code that's intentionally introduced into your supply chain, often with the goal of exploiting your software or compromising your customers. So malware can enter your software supply chain in various ways. So for example, it could be injected into an open source library that you rely on, but it could also be introduced during the build process through a compromised CI/CD pipeline, or even being embedded by a malicious insider with access to critical systems. And so unlike CVEs, malware isn't something that you can just find in a public vulnerability database. It requires active, intentional scanning and detection tools and these more robust security processes to be able to identify it. And this is just why organizations really need to expand their focus beyond just known vulnerabilities. Malware doesn't care if your dependencies are patched or if your SBOM's up to date. It exploits gaps in visibility and process. And the takeaway here is that CVEs and malware, they're complementary concerns, not competing ones. And you got to address your CVEs, but that alone is not sufficient. You also need to be looking, have the tools and processes to be able to identify malware as well.
Yeah, once again, speaks to the challenge, right? There's many links in the chain, and at each link, there's multiple different types of risk. And I think, we can't, anyone that we take our eye off of is going to be seen as an opportunity by these threat actors. And it looks like right now, malware could use a little bit more attention based on
Yeah.
the stat you found. Another interesting one. I'm really thankful that your team did this research. I think it's gonna help a lot. All right, and all right, tell
All
us
right.
about this one.
Yeah, well, I'm gonna wrap up here a little bit, and then we'll keep continuing the conversation a little bit. But from the data that I'm going to present, I just want to focus on what I think this powerful data point is that IDC research found that 83% of organizations say that securing the software supply chain will have high attention or will be a area of strategic alignment in the next 12 months. And this is really, in my mind, a clear indication that the industry is recognizing the urgency of this problem. But the one thing I want to say is that while recognition is only kind of that first step, the challenge is turning that intention into meaningful action. So I hope that throughout this discussion that I've highlighted some critical things that software attacks are shifting upstream, targeting this, moving from the application and targeting and infiltrating the supply chain itself, that the shift amplifies risk for organizations, and that one single compromise can ripple through countless organizations. And we've explored some misconceptions, I think, that can hinder this process. I really truly think it boils down to, with software supply chain, the state that we're at, is that understanding is the most important thing right now in helping you begin to secure your software supply chain. You can't rely solely on application security tools. That SBOMs are great and a process you should implement, but don't think that just SBOMs alone are going to provide you all the security you need for your supply chain. I really want to also and then emphasize that we need to look at malware just as much as a threat as we do CVEs. So where this leaves us, I think, is that the answer lies in adopting a holistic approach to software supply chain security, one that looks beyond the individual components and to securing the whole ecosystem. It really means that your organizations, you need to foster this culture of vigilance where security is embedded to every stage of the development lifecycle. It's not just treated as an afterthought. And but I do want to say, I feel like my talk's maybe been a little bit negative, and that I think this slide gives us a reason for optimism. The fact that 83% of organizations are aligning on this as a strategic priority shows that momentum is building. And I see that in my research every day, that I've been following this space for almost 4 years now. And I really do feel that this snowball is getting much bigger and much faster. And as we've seen, it's not optional, I think, is the biggest thing, that it's essential for your organizations, your customers, and just for the broader software digital ecosystem, that this is something that, as you walk away from here, you need to start thinking about, like, what am I doing in my organization, and how can I take the steps to make sure that this whole process is secure?
Yeah, that's a great point. I think this this challenge really requires us to band together, and it is really nice to see some of this happening. And in the spirit of data, we would actually like to hear from you once again. Um, which of these statements best describes your organization's approach to securing your software supply chain today? If you could take a look at the poll and place where you feel you and your organization land, we'd love to get a little bit more data on top of what IDC and Katie already have to kind of understand the state of things as this audience sees it. And I'll let these trickle in and we'll share the results with all of you once we feel they've slowed down, but they're coming in fast and furious. So wait another few seconds or so to let them come in. But yeah, Katie, thank you so much for sharing that data. For the folks on the line who are asking about the slides, they will be available afterwards. Feel free to give them their due care and attention, and leverage them to better position yourselves against this threat. As we turn to the next portion, we're going to look at the various links in the supply chain, look at the folks who are, um, carry the burden of securing the supply chain, and offer some methods that we can employ to better prepare ourselves for this type of threat. So here we have the results up on the screen, and we see once again a pretty even split here. There's 24% are not yet considering software supply chain on the org level. 16% see marginal activities in parts of the org. 36, the majority are kind of right there in the middle. And then it's almost a Gaussian curve here. And then it goes
Mhm.
down on the other end, high attention and well structured. And then at the last, we have strategic alignment with corresponding GRC policies. So sympathetic to this challenge. It's not an easy one. And hopefully this data can help you make a business case to bolster your strategies, and some of the things you learn can help out. So going to go on to the next portion of the webinar, where we're going to talk about the various links in the chain and what we're challenged with, and how we can do something about it. The first link is the software providers, the folks who are building code, who most of their incentives are to ship software quickly, but they also at the same time have to ship software securely. And sometimes those come in conflict with each other. Not always, and there's ways to deal with that. So we'll talk about that if I can get my slides to move forward. Cool. So one of the things that we talked about, and if you think back to the serial analogy, is some of the approaches to finding security, getting visibility, and getting confidence at the various stages of that software supply chain. So what we see right now is kind of a legacy approach that most have employed, that includes at the code level tools like SAST, SCA, and fuzzing. And then when the product's running, DAST, and then of course QA. But the problem is these are failing to deliver sufficient and complete security. And I think you can extrapolate that a lot of the data that we're seeing is evidence of this. And what I want to look at is perhaps it is the fact that we're not crashing the whole car, to use an analogy here. So here at Reversing Labs, we often say there's a reason they crash the whole car, and that's because only when you test an entire system and all of the components and how they're working together in a worst case scenario do you really have an understanding of how it will hold up when the rubber meets the road, to keep that analogy going. So a lot of those tools that I mentioned before, they're going to give you confidence in some of the components that you're sourcing. They're going to test maybe the engine by itself. They're going to make sure that the seatbelt works. But is there something in place that actually tests the entire software package as it's running after its complete release? And this is where a complete software supply chain approach, a modern software supply chain approach that uses binary analysis, assessing the entire binary and offering a critical build exam, can close a major gap in the SDLC. So those folks who are responsible for the software production side of things need a mechanism that will, one, not slow them down, but two, will allow them to assess the security and surface any risks in their software at the complete build level.
I love that car analogy, by the way.
Yeah, it's pretty useful. And I think that for the folks,
I'll steal
software,
that and you can use the serial one.
that's a fair trade. I'll take that. Thank you. And I think for the folks on the line who need to make a case to the organization that they need something more, I think that that's a useful one, right? So feel free to use that on the line as well. The next link in the chain that I want to talk about is the software buyers. This is especially challenging, and I know there's a lot of you on the line thanks to the poll that we did at the beginning. You need visibility into these tools that you're buying that your business relies on, and some vendors are great, some less so. But it's a daunting challenge. I want to double click on that a little bit. So when I talk to folks who are in this position, am hearing more and more often that there's no primary control for the software buyers. Yet there's still the responsibility to buy secure software. And when I look at the controls that are typically in place now, we see things like questionnaires that rely on truthful and accurate self-attestation. They're based on an inherent trust model. And I'm not saying that you can't always trust them, but if you're adopting a zero trust approach and things like that, I don't think this quite is going to get the job done. The other is SBOMs. We don't need to belabor this much longer, but they're really a list of ingredients. They're going to tell you what's in there. From it, you can glean some interesting information, but they're not going to surface risks proactively and put them right in front of you to make actionable decisions on. Next is pen testing, a fundamental practice to mimic threat actors, but they're often too expensive to scale to address TPSRM, third-party software risk management. And when I talk to a lot of the folks in this position, what they've told me is they take all their vendors, and sometimes there's 30,000 vendors. Literally, I've talked to one customer who has 30,000 software vendors, and they bucket them into high, medium, low risk category, and only the high risk ones get the full gambit of pen testing and things like that. But that leaves a lot of exposure. And they've really chosen that based on bandwidth, not based on whether they want to be pen testing all of them. All of them should be ultimately, but it's just not feasible. We're also seeing things like security service ratings. They're not gonna that are intended to convey a vendor's exposure with a rating. That's not going to identify the malware we talked about before. It's not going to identify whether their software has been tampered with. Likely, they don't even know that if they're shipping it to you. And then last, we see sometimes these tools go through a sandbox, another costly mechanism that's going to require execution or detonation. These are resource intensive, costly, and not scalable. And I think Tim Brown, the CISO at SolarWinds, who we had a conversation with recently, said it well. SOC 2, ISOs, questionnaires, information in spreadsheets, that evaluation doesn't really give you enough to be able to truly assess the risk of the product that you're buying. So I'm very sympathetic to folks in this position. These tools are not really offering what is needed to make a decision. And it all comes to a lack of visibility, right? When you get this software binary, it's often a black box. And even if you run it through an AV or check its hash or something like that, it might look fine, but that does not mean that it's not the home to malware, that it's not been tampered with, that it's not going to exhibit suspicious behaviors. One of the reasons for this is that there's a lot of components, and some tools might look at everything before the artifacts are brought in. Some tools might just look at the open source artifacts or open source software, but it's pretty difficult, especially with those legacy tools that I mentioned before, to get a complete and deep assessment of every potential risk that can be hidden within each of these components. And that's why we believe it's really essential to identify critical risks and threats within the software binary. I'll talk a little bit more about how we do it here at ReversingLabs with what we call the SAFE report. But really, in general, what I want to relay is that we need to have our buyers given the capability to take any binary that they're considering purchasing or have just purchased and to look deeply inside of it recursively unpack it to its smallest components, and see if there is malware, if it has been tampered with, if there are vulnerabilities, which is the most common one folks talk about. But again, these other risks are really worthy of our attention. See if there's opportunities to harden this piece of software, if there are secrets, if there are licenses, and all of this does need to come with an SBOM. Software buyers need a primary control to identify malware, tampering, and more, and they need it without source code because that's not available on that side of the chain. Now, on to the next, and I'm having some lag issues. All right, there we go. Going beyond the SBOM, another challenge that we see here is that even if we are given an SBOM, is it complete? And even if it is complete, it's a list. We really need to see all the risks that are associated. Third is the links in the chain. Third step in the links in the chain is that collaboration is key. Not only do we have to look at the integrity of each of these links, but we have to look at how they interconnect and how these two groups of people can communicate with each other. In a modern approach to software supply chain security, collaboration is key. We're going to see software producers, we're going to see IT security, and we're going to see risk management folks all working together. You'll see the titles here listed across the bottom, but on the left side, and think of this as well as kind of like in the cereal analogy, on the left side of the cereal supply chain, we need to be able to identify supply chain issues before release. For those folks who are working in the SOC or who are in IT security, you need to continuously monitor to see if your environment is exhibiting behavior indicative of a software supply chain attack. And then on the risk management side, you need to find hidden threats before you deploy or update software. And I want to offer a little bit about what this new era of transparency could look like, wherein software providers can understand which all of these that might be present in their code, and they can relay that information to the software buyer and vice versa. But before I do, once again, we'd love to hear from you folks here at the audience. How would you rate the level of transparency between you and your vendors? We could get our third and final poll of the day up on the screen. We'd love for you all to chime in.
I'm real interested in
This will
the
be fun.
outcomes of this one.
And 1 is we don't feel good about it. 5 is it's completely transparent. They tell us everything we need to know, and we can see deeply inside of the software packages and make our decisions with confidence.
Mm-hmm.
It's going to be another Gaussian curve, it looks like. With cloud native, it will be rated low for sure. Yeah, thanks for that. Okay. All right, I will put the results up on the screen here, and you can see most people feel kind of in the middle. And to me, that's saying we're getting the answers to our questionnaires. You know, they're answering us, and nothing's to say that these vendors aren't trying their best. But I think there's probably typically a little bit more that we could see, a little bit more that can be done to create a bridge between these two links in the chain.
And it's so important because I think we over focus on the producer side of the equation a lot of times, that just like with the supply chain, it's sort of that it's all that stuff in between, the producer and the consumer and how they work together.
Yeah, I think if there's one thing that this data highlights to me is that we need to expand the scope of responsibility and of impact on the software supply chain to cover each phase. And it looks like the buyer could could use a little bit more support there. So I'd like to close with a few slides on how we can address all the links in this supply chain and consider what can be done. At least from ReversingLabs perspective, we have a tool that allows you to generate from any software binary what we call a safe report. That tool is called Spectre Assure, and it delivers the most comprehensive SBOM and risk assessment for any application. Here you can see what that looks like at a high level. And it can be generated by a software producer to get this confidence and understanding before you ship, or a buyer before you purchase or deploy. It surfaces those key risks I talked about before. If there are licenses or secrets within the binary, if there are vulnerabilities or opportunities for hardening, and last, certainly not released, maybe last but most, if there are threats like the software has been tampered with or there is malware present. We'll give you a risk level that is top of the screen. You get a nice red or green, stop or go. We'll also give you a safe level on a scale of 1 to 5 to tell you how confident you can be in deploying or shipping this code. And we talk to a lot of security professionals who love these levels because it allows them to make risk-based decisions without having to have deep knowledge of how of cybersecurity. So you can have a meeting with your CISO as a GRC individual or a chief risk officer, and you can understand what a 3 means and a 5 means and the impact to your business. And you can make decisions and policy and enforce that policy with a tool like this. A little bit about how we could stop the next attack. So say you have SSCS policy-based controls in place and you run a binary through it and you see that there is malware present. If you are on the AppSec side of things, you can not release that code, go back, address the issue, run through it again, and get to the point where you're confident in releasing. And if you're on the TPRM, IT, or procurement side of the house, you can certainly make sure that you don't deploy this software. Make sure that you haven't bought malware, as they say. In another scenario, there might be the presence of tampering. In this case, that could be through a reproducibility build check, where it was failed and suggests that the build environment was compromised. In that case, you wouldn't release, you'd take a look at where the issue was, you would remediate, and then you can go forward with confidence. The other scenario is that there was tampering detected. This can happen on either side of the house, and this tampering could resemble what happened with SolarWinds Orion, and you can make a decision then based on that information. Another way you could operationalize this on the buyer side of the house is that you could say that every time there's a new update, a new patch, or a new piece of software that comes in, you run it through Spectra Assure. It will output all of that, those 6 risks that we talked about. It'll analyze the software binary and tell you about the presence of it. And it will allow you to make a decision based on what you've decided is your risk appetite. If it's perfect, if it's pristine, you can deploy it. If it's somewhere in the middle, you can work with that vendor to go back and change it, or you could maybe buy a different tool. A lot of our procurement folks are using this to make decisions on which tool to buy. We've also seen folks contact their vendors, show them this report, and get prompt fixes and patches that make them comfortable buying the product. Another thing you can do is say you already have the tool, but something in the threat landscape changes, like the next log4j. You can actually use this tool to assess all the applications that you have and find presence of that potential risk and then act accordingly. And then last, I want to talk about a free resource that we offer at ReversingLabs. No strings attached, really, really, really. You don't enter your email, nothing at all. If you just go to secure.software, you will see a tool that we have called Spectra Assure Community. It is the largest free resource of comprehensive risk assessments on open source software. So again, check out secure.software and you can look at a massive number of open source software packages, and you can get that exact risk assessment I showed you before, so that if you want to bring a piece of software into your product, an open source piece of software into your product, you can know ahead of time if it's going to bring in any sort of type of risk. As always, we really appreciate everyone who's attending our webinars, whether it's your first time joining us here at ReversingLabs or you've been joining us for a while now. We really appreciate it. If you have been joining us for a while, you know that we keep a steady flow of these webinars going. Coming up, we have a couple of really exciting ones. On November 21st, we have a virtual event called Global Perspectives on Software Supply Chain Security with insights from the National Cybersecurity Center and PwC. Additionally, we have a webinar on December 5th with Joe Coletta on our team and another great security expert from Thales, who are going to be talking about AI in the software supply chain, balancing innovation and security in the AI age. As I promised, we really do want to hear questions that you have. So at this point, I'm going to bring up our questions panel, and we'll start taking questions from the audience. Bear with me for a moment here. Okay, great. Some of the questions that are coming in. What's your opinion on EU DORA regulation? What kind of drawbacks or shortcomings in this act? That's actually one where I would encourage you to check out some of the content that we have on very soon. Tomorrow we have a webinar that's going to address this. It's going to be a great topic. I think like any regulation, it has the best of intentions, and this one is going to be really beneficial if we can comply. But complying is often strenuous, and so we definitely recommend checking that webinar on what its impacts might be.
Yeah, I agree. I was going to say, not specifically DORA, but one of the interesting things we found in our research was in my survey, I cut all of the data by those industries that were more likely to be impacted by software supply chain regulation and those that weren't. And we generally found, especially responses that were aligned around compliance, that those in that sort of highly impacted bucket were much more likely to be doing those practices, which really the bottom line of that says to me is that compliance works, and these regulations do drive action from organizations. But like Dan said, I also recognize it's not necessarily the easiest thing to do to have to figure out how to comply with all of these things.
Yeah, absolutely. Well said. Thank you, Katie. Another one that I'm interested to hear your thoughts on, Katie, is someone says, what about zero-day vulnerabilities? Did your data source anything about that, or do you have any thoughts on zero-day vulns and how we should think about those?
Yeah, that's a good question. And so I think you saw on one of the earlier slides when I think the lowest of the like what types of security incidents did you experience in the last 12 months was 0 days. Which makes sense because a lot of times you don't even know you're impacted by them. But in my opinion, I think the important thing is that 0 days are probably one of the hardest things to prepare for because you don't know what it's going to be introducing. So I like to think about it and how like I think about organization and life in general, that like if you're planning and controlling all the things that you can control, typically when you have these things that you have lesser control over, their impact is lesser when you already sort of have all of these other systems in place. If you have a great security processes around your software supply chain, when these 0 days do come up, they're probably going to cause some level of panic and scramble, but you're going to already sort of have a lot of the pieces in place that are going to help ensure you're protected against them. A lot of times runtime oriented protections can really help with 0 days. If you have very good control over and visibility over your build systems and good insight into your, if it's an open source 0 day, if you do have, again, we're SBOMs where those kinds of things can be really helpful. So I think it's like, you control all the things you can control so that when the uncontrollable inevitably happens, it's less of a fire, right, than it would be if you have none of these things in place.
Yeah, absolutely. Well said. Thank you, Katie. A couple other questions about, will we get the slides? Yes. And it was mentioned that the slides were a little grainy. Apologies for that. It's high def on this end. So once you get them, you will have a high definition slide. So anything that might have been unclear before will be available to you afterwards. Another question, and we're about at the top of the hour, so we're gonna have to wrap probably after this one. But in terms of supply chain stakeholders, are you seeing a balance of urgency lie with the CISO org as opposed to the DevOps AppSec teams? Katie, really interested to hear your thoughts on that, since because of how close you've been to this issue.
Yeah. I honestly, so actually we did, this is a survey. So last year's survey, we're going to do it for this year's data as well with my colleague that lies more in the cybersecurity group. And, I tend to be more tied to the app devs, right? And covering DevSecOps and the like. And we will analyze the results by those two different personas and look for differences. And we did find in last year's results or last year's survey where I had several software supply chain security questions that generally the app dev side of the house seemed to have higher recognition of these concepts and processes, or felt that they were doing more software supply chain related things than those that were more on the cybersecurity CISO side of the house. But I do have to say, I get to talk to a lot of CISOs in my job, and the topic of software supply chain is coming up more and more as a kind of aligned with that, data at the end of the presentation, as that this is becoming a strategic imperative at organizations where they're really starting to have to address some of this stuff beyond some of the basics, right? And so I think right now I would say if there was like I think pendulum, where maybe a little bit more on the app dev side in terms of awareness, but I see it every day growing as an organizational priority.
Sure. Yeah, a lot of change, a lot of building, a lot of rebuilding right now. So the answer on the next webinar we do might even be different.
Yeah,
So,
we'll do
yeah,
round two a year from now.
yeah, that sounds fun. We'll do that. So with that, we're 1 minute before the end. Our timing was good here. Thank you for the questions. And thank you to the audience for joining. We really do appreciate that. We appreciate your questions and your feedback. Follow us on social for more like this. And Katie of IDC, so good talking to you. Thank you so much
Pleasure
for
to be
sharing your
here.
data and joining us today.
Yeah, you're welcome. This was great. Thank you. Appreciate it, Dan.
Absolutely. All right, folks. Well, have a great one.